Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to go through a couple examples of variation. So the first example we're going to look at here, I've written it up here, example number 1, and my writing could be a little better, so let me just walk through this. So if y varies directly with x squared and y equals 5 when x is equal to 3, what is y when x is equal to 8? So the idea here is that we want to use the concept of proportionality or variation here to try to relate x and y so that we can figure out what y is when x is equal to this value. And the key is understanding this first line. If y varies directly with x squared, let's start with that. Now, hopefully you've seen my video on variation. If y varies directly with x, or maybe in other language, if y was proportional to x, that would mean y equals a constant times x. However, here, it doesn't vary directly with x, it varies with x squared. So we would just write, okay, y equals a constant times x squared. All right, so that's what direct variation means. If this had said y varies inversely or indirectly with x squared, this would read y equals a constant over x squared. But I'll save that for another example. All right. Now what I'm going to do is I'm going to take the values that we know here and put them into this equation that I've written. So if we do that, this is going to read 5 equals a constant times 3 squared. And what this will allow us to do now is find our constant. So let's see, 5 equals a constant times 9. And when we divide by 9, we have that our constant is 5/9. So now what we can do is we can update here our equation and rewrite it. Y equals 5/9 times x squared. And now what we can do is take our new value of x, 8, put it into this equation here. So y is going to equal 5/9 times 8 squared, which is 5 times 64/9. And if you'll give me a moment here, I'm going to use my phone here to calculate a value. So let's see. And what I get out of that is 35.6, rounding it to a tenth place. Now, you can also leave this in fraction form as an exact answer. It's the engineer in me that likes to round to decimals. So I think what I'm going to do now is pause this video, make up another example, and work through that. So if you'll bear with me. Okay, folks, I'm back here, and I've made up another example for us to look at. So first, let me go through it with you. So if y varies inversely with x cubed, and y is equal to 10 when x is equal to 3, what is y when x equals 1? All right, so the key to this is starting here. Right? If y varies inversely with x cubed, and again, another way this problem might be worded might be something like y varies indirectly with x cubed would mean the same thing. That would allow us to write this equation out. That means y equals some constant over x cubed. And again, this constant, we can call it anything. You can call it a, b, c. Some books like to write k for their constants, but I usually just use c for constant. Big thing is knowing that because the word inverse is used, the x is being in the bottom, and it's not just x, it's x cubed. Okay, now what I'm going to do is just use the values given. We know that when x is 3, y is 10. So I'm going to put these values in. This is now going to read 10 equals a constant over 3 cubed. And now what we can do is solve for c. So c is going to equal, if we solve that for c, let's see, 3 cubed, 3 times 3 is 9 times 3 is 27. So c is going to equal 10 times 27, which is 270. So that means that we can rewrite our equation now, y equals 270 over x cubed. Now we'll just put in our new value. When x is equal to 1, y is going to equal 270 over 1 cubed, which is 270. And there's the answer to our question here. So hope this example helps with solving problems about variation. Have a great day.